In this video, I'll be working through the questions you see on the screen, and this question is from the winter edition of Cambridge International Exams from 2023 from paper 1-2. If you want any other questions from this paper, there should be a link to a playlist in the description below. I do these on a whiteboard, hopefully to mimic how you're used to watching your teacher teach these questions. And if you find any of this useful in any way, please like, subscribe, and even share it with some friend that's doing the exams or someone doing it next year. In question 4, we're given this shape here that's made up of 3 parts of a circle. And in part A, we're going to be asked to find the perimeter, and in part B, we're going to be asked to find the area. So to discuss more about the shape, they also tell us that this is 2 centimeters or 2 centimeters across, and they tell us ABC here makes up a equilateral triangle. That's very important. But yeah, they tell us that the circle that's made of AB has a center at C. So you can think of a big circle that goes around. And the same for AC having a center at B. Again, a big circle that goes around. And where's the last one? This one here goes a big circle that goes around. That's how you make these shapes. So another way to look at this would be to break it up into the segments. Let me draw it out again. Break it up into segments like that. So that'd be B, C, and A. And you could get 2 more pointing different ways and stuff. So we have a formula to get the length of this. Oh, I should say at this point that they don't tell us to use radians or degrees, so you can use anything you want. I will go ahead and use radians whenever I can. First of all, they usually ask you to use radians. Second of all, it does work out easier in the long run if you learn how to use radians. And yeah, I guess there was only 2 reasons there. Okay, right, now what angle's in here? That's the trick in this question that you need to know from the start. They do help you. They tell you this is an equilateral triangle. So you should know this is 60 degrees, or in radians, pi over 3. Remember, a pi is 180, pi divided by 3 is 60 if you want to try and convert it. So we know the length here is 2, equilateral triangle, 2, 2 and 2. So I'll throw up on the board from your formula page the formulas you're going to use. And it tells us that the length here, let's say L is equal to or theta, where or is 2 and theta is the angle. So that's pi over 3. So that's the length here, and the perimeter is just 3 of them. So we just get the perimeter is 3L. Let's write it as, that's 3 times 2 divided by 3 times pi. 3's cancel, and we're left with 2 pi being the perimeter of this object here. Now to get the area is going to be something similar. Well, let me clear this off so we have plenty of room. So to get the area of this shape, it's not a standard shape, so we don't have a formula. You need to break this up into things we can get. And well, here's one way to do it. So this entire shape is equal to a triangle plus a some sort of shape like this, plus the same shape again, plus the same shape again. Now this shape appears all the time in your exams. I'd say 80% chance, 90% chance this will be on your exam in future, a shape like this. Again, something that will start like this and you have to break it up, but it all boils down to, you can get a triangle, you can get a wedge, but how do you get one of these shapes? So another way to break this up would be, by the way, let's see, a wedge like this plus again this shape plus this shape. But again, the problem with this is we have a formula for this one, we don't for these two, all of these. So the question really boils down to, how do you get the area of one of these shapes? And like I said, it comes up all the time, and so I'll do that separately here. This shape is equal to this shape minus the triangle. And that will literally come up so many times in the exam. In this case, the formula for a segment of a circle is a half or squared theta, that's in radians, minus the formula for a triangle. Remember, we know the angle, pi over 3, we know the lengths on either side of it. The formula for this is a half side by side, 2 squared, times sine of the angle. So that will get us the area of this shape. Let's do all that out here. Yeah, I don't think I need much room for this. Again, we have the angle there. So that's a half 2 squared pi over 3. We can clean that up. Minus, let's see, two of the 2's cancel. We have a 2 there. Sine pi over 3 comes out as square root of 3 over 2. I'll just double check my notes on that one. Yeah, it does. The 2's cancel. We clean all of this up. Let's see, we get 2 over 3 pi minus square root of 3. Yeah, okay. So that's the area of one of these shapes. So if we want to do this one up here, let's do the entire shape up here. We have the triangle, which we've just done, is square root of 3. That triangle, square root of 3, plus this entire thing times 3. So plus 3 times 2 over 3 pi minus square root of 3. Now we need to clean that up because they did actually ask us to put this in a certain form. Oh wait, no, actually that's a later question in this paper I'm thinking of. They just asked us to be in terms of pi and square root of 3, so I think you'd get most of your marks here, but you can clean this up a lot. Square root of 3 plus 3 times this would be 2 pi. 3 times this would be minus 3 square root of 3. These two go together. That's 1 square root of 3's minus 3 square root of 3's. So we're left with 2 pi minus 2 square root of 3. Yeah, that's the full answer for the area of this question. And again, if you had done it this way, you would have still had to get this shape over here and multiply it by 2, I guess, and you would have had this segment, and hopefully it would come out the same. I haven't done it that way, to be honest. But if you have any follow-up questions, please let me know in the comments. Thanks for watching and have a great day.